Let's consider two quadratic functions and solving some of the related quadratic equations and inequalities. So first, let's think about the function f of x equals x squared minus 4x minus 5. What if we wanted to solve x squared minus 4x minus 5 equals 0? Or we could also call this, when is f of x equal to 0? So this is one that we can factor. So we could factor this to x minus 5 times x plus 1 equals 0. Solving this by setting each of our factors equal to 0, we get two solutions, x equals 5 and x equals negative 1. Or we could also write this as a solution set using our curly brackets. Let's consider a similar problem. G of x equals negative x squared plus 3x plus 10. So let's solve this one. Solving when is negative x squared plus 3x plus 10 equal to 0. Because this has that negative out in front, to make things a little bit easier for factoring, imagine factoring that out. X squared minus 3x minus 10 is equal to 0. So we could divide both sides by that negative 1. Think about factoring that polynomial that's left. So things that multiply to negative 10 but add to negative 3. You can do a minus 5 and a plus 2. So we get two solutions, x equals 5, x equals negative 2 on this one. So what would these functions look like if we were to graph them, focusing in on their x-intercept as some of the key points that we need to take a look at? So in both cases, these are parabolas that open facing upward. We could find the vertex. Don't worry about that too much for right now. So the key thing is that negative 1 and 5, those solutions to where f of x is equal to 0, those tell us about the x-intercepts of this parabola. It opens facing upward because our value for a is equal to positive 1. If we go to graph this second parabola, because g of x starts with a negative 1 as its value for a, this parabola opens facing downward with an x-intercept at negative 2 and an x-intercept at positive 5. So now what if we wanted to solve the inequalities that were related to this original function? So what if we wanted to know, when is x squared minus 4x minus 5, when is that less than 0? So when we're looking at the graph, this corresponds to where this is below the x-axis. So for a parabola that opens facing upward, the part that is below the x-axis is this part that is in between our two x-intercepts. So in interval notation, the part that is in between the x-intercepts is going to be negative 1 to 5, parentheses on this one because it did not have equal to 0 as an option. Whereas on this second function, where is negative x squared plus 3x plus 10 less than 0? So we're still thinking about the below part. For a function that opens facing downward like this, it's the two outside tails that are down below the x-axis. And so for this one, we would have two separate pieces to our interval notation because there's two separate tails that are down below the x-axis. So it would be from negative infinity to negative 2 and also from 5 to infinity. So what about greater than 0? So where is x squared minus 4x minus 5 greater than 0? So now we're thinking about being above the x-axis. Well, there are two tails on this one where it is above the x-axis. So we're going to have two pieces to our solution set here, from negative infinity to negative 1 and also from 5 to infinity. So for a parabola that opens facing upward, you're going to have two parts of your solution for where it is greater than 0. But if your parabola opens facing downward, so when is x squared plus 3x plus 10, when is this one greater than 0 and above? Well, for this one, it's that part in between our x-intercepts, and so there's just one solution to where this one is above the x-axis, just from negative 2 to 5. So when we're solving quadratic equations and quadratic inequalities, it's important to know whether our function opens as a parabola facing upward or facing downward. If you have a parabola that opens facing upward, when we solve the equation that tells us about our x-intercepts, the less than 0 will be the part in between those x-intercepts where it's down below, so just one set for that solution, and the part where it's greater than 0 will have two sets in its solution. But if your parabola is opening downward because of a negative value for a, for the part where it is less than 0, you'll have two solutions, and the part where it's greater than 0, you'll have one solution. So find your x-intercepts by solving the equation, and then think about the graph when you go to solve the inequalities.